Alright, this is a quick video response for 5H2. Let's start with problem number 8. It gives you this equation. The score is 78 minus 15 times the log of t plus 1. And parts A, B, and C are all kind of summarized over here. If you have an input of 0, the output is 78. You can just use I use Desmos to do a quick input-output table. If the input is 4, then it's 67. If the input is 24, then it's 57. You can see right here it gets plotted automatically even with Desmos. And then the graph is right here. You can see it's kind of the upside down log curve. You might remember a log curve going like this, and then leveling off. But here it's because of this negative symbol, it's been vertically flipped, vertically dilated. And so it comes in from positive infinity and then will level out here. It will go as low as you want it to, but it will never, but it takes a long time to get there. Anyway, part D is maybe a little bit trickier. If you give it an output of 50, then what would the input have to be? What would the time? So you put 50 over here, and then you can subtract 78 from both sides, divide both sides by negative 15, and then this is a log equation. Remember, the base is 10. It's unwritten beforehand, but I decided to write it here to help us remember how to flip this around. Here's the base, here's the power, and here's the exponent. Again, base, power, base, exponent, power is over here. So then you can subtract 1 from both sides, and then you get 10 to this number right here, minus 1. And a calculator tells you that's about 72 months. And so I typed in 72 right here, and just to check it, if the input is 72, then the output is indeed about 50. And it gets plotted right here. That's problem number 8. A lot of the other problems are very similar. Number 14, 18, and 31 all are pH formula problems. And so I decided to put the pH formula right here just as a quick reminder. There it is. If you're given a hydrogen concentration of this number, then you can put it into the formula, and then you hit enter on a calculator, and it gives you about 7.8. That's mostly because of this negative 8 right here. You can see the log of just, forget the 1.6. If this weren't here, it would be exactly 8, because the log of 10 to the negative 8 is negative 8, and then the negatives will cancel out to positive 8. So here, in orange juice, they're given a pH of 3.2. That's kind of the output of this formula. So you put it over here, and you have to find the input. You have to solve for the hydrogen concentration. Multiply both sides by negative 1. Rewrite as an exponential equation, 10 to the negative 3.2. That's about 0.00063. And if you wanted to write that in scientific notation, as scientists often do, then you can do this. But I would accept this as a math teacher. Either of these answers are fine. And if you needed to solve the pH formula for the hydrogen concentration, you'd have to, very similar to this problem here, you'd have to multiply both sides by negative 1, and then rewrite as an exponential equation. The base is 10. It's unwritten here, but the base really is 10. I wrote it here. And then the exponent is this, the power is this, and the base is 10. So hydrogen concentration is equal to 10 to the negative pH.